Hello and welcome back to the shop. So in today's video I'm going to be making a tool, although the tool is going to be for the wood lathe here. So the backstory is I joined the local Woodturners club in February this year. Now every Wednesday night they have someone doing a demo. Now these demos can be generic wood turning demos like making a bowl or a round box, or they could be a whole bunch of other types of topics like colouring and carving, off-centre turning, all sorts of things like that. Anyway, foolishly I put my hand up and said that I will do a demo, and the demo that I'm going to be doing is threading on a wood lathe. Now on a wood lathe there's no levers and dials or anything on this side that you can dial up a thread pitch and turn a thread on a wood lathe. And as you can see, the banjo here is pretty much, locked in place. That's where the tool goes to do your turning. So there's no carriage movement here that would move at a certain rate in relation to the spindle to cut a thread. So what I'm going to have to do is make a jig which will be able to cut a thread in a different way to the traditional thread cutting on, say, a metal lathe. Let's go over to the workbench and I'll show you what ideas I've got. Now straight off the bat there are some tools out there called thread chasing tools, and a lot of wood turners use these to cut threads. Now the issue is that you need a lot of skill to use those tools, and to get a lot of skill you need a lot of practice. So you're likely to make a lot of threads that don't work before you start making threads that do work. And there's a few other inherent issues with using thread chasing tools, and that is trying to get your threads parallel and the correct thread depth, and trying not to cross thread and things like that. There's a whole lot of issues and there's a whole lot of skill that you need. So with a threading jig you would take a lot of those issues away and you would be able to cut almost perfect threads even if you haven't cut threads before. So the learning curve with a threading jig is quite small compared to using the thread chasing tools. Okay, so this is what I've put together at the moment for a rough mock-up. In the chuck here we have a cutter. This is a double angle cutter, so it's got a bevel on that side and it's got a bevel on that side, and that angle in there is 60 degrees, which is the same angle that you need when cutting threads. So on a metal lathe, as you know, when you're cutting threads you'd sharpen the tool to a 60-degree angle. So that's all good. We've got that in a chuck. This chuck is a Morse taper 2 chuck, and of course the wood lathe has Morse taper 2 in the spindle. Now there are a bunch of other ways you can hold the tool. You could hold it in a MT2 collet. You could make up some adapter that fits on the spindle thread of the lathe, and it has a grub screw that holds the tool bit in. So there's a bunch of different ways you can hold the tool. Now the tool spins with the lathe and that just stays stationary. So that's our 60-degree cutter spinning, ready to do the work. What we have on the other side is the jig. So we have a tool post that goes into the banjo, and it has a mechanism up here where this connects to. So I have to work all this part out. Probably use dovetails or something like that, because what we need to do is we need to have some sort of dial control on here where this can be moved in and out, and that's going to give us our thread depth. And basically that mechanism up here fits around the outside of here, and there is a thread cut into the spindle that holds the chuck and ultimately the work that we want to thread, and this screws into that holder. So basically we can have a thread, say something like 16 TPI, and then this gets turned by hand and the cutter engages the side of it here, and that is how the thread is cut to that TPI. Now on the internet there are a bunch of jigs like this, and they all do pretty much a similar thing. So it has that adjustment in and out, and it has some sort of thread here, whether it's 16 TPI or 12 TPI, 20 TPI. I mean, you could have anything here. You could have a metric thread or anything, so it really doesn't matter. But 16 TPI is a very common one that is used particularly on those chasing tools and threading jigs as well. So I think we'll stick with the 16 TPI in this case. So when the jig has been built and it's all ready to go, this part will be locked into the banjo, so that won't move. It'll be all connected through here, so this will be all pretty solid. And then all we need to do is to work out our height, and that's pretty easy, because what I'll do at the end here is I'll put a center in there, and then we can line that up with the tailstock. So that'll give us our height at the correct place. And then we just need to make sure that we're parallel this way with the spindle. And that's pretty easy, because we can put a ruler on the edge of the chuck here, and we can line that up with the lathe bed. And then once that's parallel and we're at the center height, then we're pretty much good to go. And then it's just a matter of how deep to do the threads, and that all comes down to this control that we have on the front here to move the whole spindle in and out, and that will be worked out with a thread that matches one complete turn for the depth of thread, but I'll talk a little bit about that later on. Okay, so I think the first thing I'll work on is the mechanism of sliding in and out here. And as I mentioned, I think a dovetail would be quite good to use there. And then we can get it into the right position and then lock down maybe a screw at the top with a hand lever. And then that will pull the dovetails together, which will keep everything nice and secure, and it won't be able to move. This is 50mm by 20mm hot rolled steel. And hot rolled steel is not completely flat, so I put it in the mill and clean up all the sides and edges to get it nice and flat and square. I machined one piece long enough so I could make the two halves of the dovetail, so I cut the piece in half. Then I start milling out the slots to the depth that I need with the standard straight end mill. And once that's done, I come back in with the 60-degree cutter and cut the dovetail. And it's pretty much a rinse and repeat for the second half of the dovetail. First go in with the straight cutter and then come back and use the 60-degree cutter. Once machined, I tested out, and this actually turned out to be a really good fit. And you can see by my expression here that I am absolutely over the moon with how good this turned out. This is a piece of 40mm by 40mm square bar. I need to cut a M10 by 1mm thread into it. Also, I need to mill out the sides here, and that will be for where the tool post holder bolts onto, and it will have the ability to be hinged. I also need to drill and tap 2 holes in the top dovetail, and that's for a plate that gets fitted on there. That block is cold rolled steel, so again I'm just flattening down and squaring up the faces of the block. Now I've put some chamfers around that block because that block will be welded to the bottom dovetail here. And I'm using a nice flat surface here to clamp it all together with a can't twist clamp. And then I go ahead and weld that block on and then clean up all the welds. Now I start working on that plate. This is 50mm square by 5mm thick flat bar. That plate goes on there and I need to drill and tap 2 holes through there. And then there'll be a knob for the adjustment that'll fit on like that. Instead of trying to hold everything together, I thought I'd just tack it in place and then I'll be able to drill and tap the holes quite easily. So start with a centre drill and then come back with the main drill. And I was using both the ABS and the incremental modes on the DRO here to get the spacing correct. First time I'd used both of those controls. The threads are tapped out to M6. Now I've put it all together and I've ground all the sides down so they all match up nice and smooth, and the mechanism works just like that. The next step is to drill that M10 by 1mm pitch thread around about here. I dial it all back in the mill and then drill the hole out for the M10 thread. And I've removed that plate now and I'm just tapping out that thread. Now I also reamed that plate out to 10mm as well because I want a nice snug fit there. Next I start working on the part that will do the adjusting, and this is 20mm round bar. I clean it up in the lathe and then I turn down one end, and that is the end where that little plate goes onto. Then I turn it round and I prepare it for threading. So I've got a little recess at both ends here. And then we go ahead and cut the M10 by 1mm pitch thread. And I try that on and that works out very, very nicely. That screw goes into that part there. And then the dovetail slides across. It all lines up beautifully. And then the next part is to work on the adjusting knob. This is a bit of aluminium I found. I think I've home casted this. It already had a hole in it. I just run the 10mm reamer through there. Then I clean up the end, which gave a very nice finish. And also along the side there. As this is an adjusting knob, I'm just putting some knurls on it as well. So I cut out a bit of a groove and then I use the cross slide to put an angle on the end here, and then once I've got a bit of an angle then I go straight in and part it off. The angle is just for aesthetics. My magnifying glasses hit the boom for the camera and we get a bit of a shaky. So the knob will fit on there, and then I need to drill and tap a grub screw that goes in there, and also I need to grind a flat onto that bar so that that knob can be held on tight. And on the other side I'm going to make up a little ball detent, and then I'll have these 5 dimples around here, and that will allow us to be quite accurate with how much we need to turn this adjusting knob to get the right depth of cut when we're doing our threading. So this is just simply drilling a hole right through here and tapping it for M6 for the grub screw to go through. And I cut a matching recess in the shaft for that grub screw. Here again I'm drilling and tapping a hole for a M6 thread, and this is going to be the ball detent that will allow us to move the dial in certain increments. I was going to make the ball detent, but it was quicker for me to jump in the car and just go buy a couple from up the road there. So anyway, the handle gets locked on and then the ball detent is screwed in there and you've got some adjustment. Now moving it around there gives us a witness mark, and that's what I'll use to mark out the 5 points. I take the plate back off and I mount that up in the 4-jaw chuck, and then I'm just using a tool here to make a line, and that will allow me to mark out my 5 points. I'm setting the lathe up with my homemade indexing plate. This has a ring of 30 holes, so if I move every 6th hole, then I'll be able to get 5 equal spaces. And that's what we're doing here. We're marking out those 5 spaces using that indexing wheel on the back of the spindle. Then I center punch them just so I can get the drill in the right place. Here I'm using a 3.5mm drill bit, and I'm just touching that surface ever so slightly. It's just putting a little dimple there, and that is probably more than enough for the ball detent to sink into when it's been used. Now I need to work on the locking mechanism, and I'm going to use this handle, and it's going to go around about here. Once tightened up, that will stop this top dovetail from sliding back and forth. I'm going to repurpose this bolt, which will screw into the top dovetail and push against the bottom dovetail, and that will push the dovetail angles together tightly, locking the mechanism. There's also a big flat area on the bottom here as well, so that will help with putting a lot of pressure on. Now this is an imperial thread, it's 5/8 x 18, so I have a tap for that. Also, I have to turn down this piece so it fits the metric handle. And there's plenty of room here to do that because I'm only going to be using a little bit at the end here to go through that top dovetail. I start by turning off that hex that was on that threaded bolt, and I also need to take off those old imperial threads so that I can get the die on to cut the M12 threads. And that's what I do there, is cut the M12 threads. I didn't show this on camera, but I cut down the bolt to the right length and Loctited it into the handle with 601 Loctite. The next step is to then drill out the top dovetail, and I'm drilling this out to approximately 14.5mm. Then I use the 5/8 by 18 tap to tap that hole. I've got the mechanism assembled and I screw in the locking handle here just to test out the locking function. That works fine. When I turn this adjusting handle, I can feel positive stops when that ball detent drops into one of those holes. I've just turned that 5 notches and that measures exactly 1mm. Next I work on the post that bolts to the bottom of the mechanism and goes in the banjo. This is 32mm round bar. I get to use the big lathe again, so I'm just facing off the end here. And then I clean up the outside. I turn this down to 1 inch, which is just under 25.5mm. It's not a good shot, but this is the square block under the mechanism. I need to cut a lot of this away, so I need to cut the sides off, just leaving a narrow piece in the middle. And then with the round bar, I need to do the same here. I need to cut a slot down the center that matches that piece in the square block, and then that will fit on and a pin will go through it. So this is going to be about 14mm wide. I start on the dovetail part and I mill down each side, and I actually leave that centerpiece 12mm wide, so there's more meat left in this part here. So this is milled out to 12mm as well. And because there's a curve right at the end there, I put it upright in the vise and just tidy up the bottom of the slot there. Now I've clamped the dovetail and the tool post together here, and then I drill the hole for the pivoting bolt. This is a 8mm hole. I quickly move the jack before we drill right through. I come back and ream that out to 8mm. Now the two parts need some chamfering or radius there, so I just do that on the belt grinder so that they fit and pivot properly. This is just a quick test fit up, and I'm just using an 8mm drill bit for the pin at this point. That's the upright position, so that's when we're checking the thread, and then when we're cutting the thread it's down in that position. I need to drill a locking pin hole there, and I also need to drill that hole when the part is in the up position as well, so that the locking pin can hold the chuck out of the way and it doesn't fall down. This is an old cut-off stainless bolt that I found, so I thought I'd make the hinge pin out of the stainless steel. I turn the diameter down to the right size we need, and then I cut the M8 thread on the end of that, and I test the part on, and that is a real snug fit, and then the nut works nicely as well. And lastly, I just cut that off with the angle grinder, and I also cut a slot for a screwdriver in the end of it as well. The next step is to drill the hole for the locking pin. This is a 6mm hole that goes right through, and I also need to drill through when it's in that open position as well. And I needed to tap the bottom hole, which is straight in line with the top hole, so I just tapped all the way down from the top into the bottom there. Then I come back later on and I drill and remount that top hole to 6mm. Now I start making the locking pin, and this is just a bit of scrap I found which will do the job. So I start cleaning that up, and then I knurl the end down there. That's going to be where you hang on to it to tighten it up and loosen it off. Then I take down the diameters. The skinny diameter is inside the mechanism, and the wider diameter is just to give a bit of length on the outside, and that is tapped to M6. Then I cut it off in the lathe with the parting tool. Now I'm cutting it to length here, and to get rid of that centre that's in the threaded end. The last part to make is a locking ring for the tool post to set the height. This is 40mm steel bar, and I clean up the face and clean up a bit of the surface and then start drilling it out to 1 inch. Now when I was making this, I thought I'd make more than one because these will be useful parts to use on other tool posts as well. So I just cleaned up a bit more of the face, and I'll cut several parts off this piece, and that gets parted off. It's a simple part, it's just a ring with a M6 thread in it and a grub screw, so it didn't take long to make this part. Okay, so I've got up to what you see here in the build, and I'm going to do the second part where the spindle goes on here in the next video. But let me go over what we've done so far. So we've got a collar here. This is a height collar, so we've got a grub screw in there so we can adjust the height, and the height will be set at center. Well, the work that gets held in the chuck here will be at the center height, the same height as the chuck on the lathe. And to determine that center height, it's quite easy, but it's actually on the next piece that I make, so I can't show you here. So we'll come back to that in the next video. But just so you're aware, we can adjust the height to where we need to have it for cutting the threads. So there's two parts to this upper piece, or two sort of functions. One is this top dovetail slides in and out, and two is we can lift it up on this hinge to get the work out of the way so that we can test the threads without it being in the way of the cutter, which will be in the chuck that's attached to the lathe. So let's first look at the hinge. So I've made up this custom bolt. It's another one, nice machined fit, so it's nice and firm in there. And this just hinges like that. So it's just on a pivot bolt in the middle, and then there's a hole here so we can put the bolt back in and just turn it a couple of turns, and then it'll stop this piece falling down and banging into the cutter. And then once we've checked the thread, and if it's not correct and we need to put it back down to cut some more, we just again unscrew a couple of turns there, make sure it goes completely home, and then we wind this one in and just tighten that up and lock it in place. Just has to be done by hand, and that is absolutely firm, nice and solid. The second part is this locking lever on the top, and then from here I can actually wind this in and out, and this is so that we can cut the depth of our thread, whether we're cutting on the inside or the outside. So we need to turn it one way and then the other way depending on what we're cutting, whether it's the lid or the box part. This has 5 positions that it goes round, and every time this grub screw comes to the top, that's kind of our home orientation. So that comes to the top. One complete turn is 1 millimeter of travel in or out. So I did put a reference line on the side here on the top and the bottom dovetails, and that's kind of our, again, home position. And then we're cutting the thread from this line. So if we were cutting a 1 millimeter deep thread, then we would turn this 5 clicks and then we'd lock it down, and then that is moved 1 millimeter. That looks quite a large gap there, but I assure you it is exactly 1 millimeter. And then of course if we're cutting on the other side, we would go 2, 3, 4, 5, and then that's 1 millimeter back from that mark there. So I'm going to wrap up this video now, and as I said, I'll come back with part 2 where I make the spindle and the other parts, and then we'll be able to see the threading jig in action. I hope everyone has a great day, and once again, thanks for watching.